going to demonstrate the law of the conservation of energy. This law states that in an isolated system, the total amount of energy is constant. That energy cannot be created or destroyed. It's simply converted from one form to another. So for instance, with a pendulum, gravitational potential energy is converted to kinetic energy. If I hold the pendulum at a height, say, half a meter above its equilibrium point, it now has a certain amount of gravitational potential energy corresponding to that height. And if I release it, then that potential energy becomes kinetic energy. And so, let's say we want to find the velocity of the pendulum as it passes through its equilibrium point. Well, all we have to do is calculate the potential energy at this point, and then set that equal to kinetic energy, because at the equilibrium point, the kinetic energy is maximized. So all the potential energy becomes kinetic. One way we can express that mathematically is using the equation mgh equals 1/2 mv squared. Now, we know the height that we listed from equilibrium. We said it was half a meter. We know the gravitational constant, which is 9.8 meters per second squared. And the mass doesn't really matter because it cancels out on both sides. So now, all we want to do is find the velocity, and then it's just simple algebra and we isolate. And if you actually do it, you'll find that it's about 3.1 meters per second. So, that's conservation of energy. That's how to apply it in a simple physics problem.